Hey, welcome back. In the last example of the previous video, we saw that quadrilaterals that are equiangular are not necessarily similar, and quadrilaterals that have sides in proportion are not necessarily similar. However, in this video, we're going to learn that if triangles are equiangular, then their corresponding sides must be in the same ratio, and vice versa. Coming up. If triangles are equiangular, then their corresponding sides must be in the same ratio, and vice versa. So, to show that two triangles are similar, we only need to show that one of these properties is true. Hence, two triangles are similar if either their side lengths are in the same ratio or they are equiangular. Note that either of these properties is sufficient to prove that two triangles are similar. Since the angles of any triangle add up to 180 degrees, if two angles of one triangle are equal to two triangles of another triangle, then the remaining angles of the triangles must be equal. Now make sure you pause the video here and you make sufficient notes in your book, because we're going to be using these concepts in the forthcoming examples. Let's move on to an example. Show that the following figures possess similar triangles. So here we have a figure where we have two triangles and a set of parallel lines. Triangles ABC and DBE are equiangular. So we're looking at ABC and DBE. Now, since we have a set of parallel lines and we have a traversal, this angle here, alpha 1 and alpha 2, are corresponding angles. So these two angles are equal. Angle B is common to both triangles. Therefore, the triangles are similar. So if I take you back to the previous note, since the angles of any triangle add up to 180 degrees, if two angles of one triangle are equal to two angles of another triangle, then the remaining angles of the triangle must be equal. Since we have a set of equal angles and a common angle, the triangles must be similar. Let's move on to another example. It says, show that the following figures possess similar triangles. We already know that this angle and this angle are equal. Pause the video here and attempt to answer this question on your own. So you may have done something like this. Triangles PQR and STR are equiangular as alpha 1 and alpha 2 are equal, and that information is given to us. And then beta 1 and beta 2, so these are equally opposite angles. So therefore, the triangles are similar. Let's move on to finding the lengths. Once we have established that two triangles are similar, we may use the fact that corresponding sides are in the same ratio to find the unknown lengths. So let's look at an example. Establish that the following pair of triangles are similar and find x. So in this figure, we can see that we have a set of parallel lines and two triangles, one large one and one small one. So triangles ABE and ACD are equiangular since we have a set of parallel lines and a traversal, alpha 1 equals alpha 2, because they're corresponding angles. You may have also noticed, because of these parallel lines and this traversal here, AD or AED, that we have another set of corresponding angles. So we can state that beta 1 equals a beta 2 because they're corresponding angles. Therefore, the triangles are similar. Pause the video here and attempt to complete the question by finding the value of x. So you may have done something like this. Since we know the triangles are similar, the length BE corresponds to the length CD, which should equal the same length ratio as AB to AC. We don't know the value of BE, as it's labelled X. We do know the value of CD, which is 7. AB is 6, and AC is 6 plus 4. So therefore, X is equal to 6 over 10 multiplied by 7, which gives us a value of 4.2 centimeters. Check back when you're working out. Did you get the same answer? 4.2 centimeters? If not, look through the working out and make sure you understand what we've done. Okay, stick with me because I'm going to recap. I'm going to make it really simple and give you a trick on how you can work this one out. Step 1, label equal angles. Step 2, show that the triangles are equiangular. Step 3, put the information into a table, showing the equal angles and the side lengths opposite the angles. Step 4, use the columns to write down the equation for the ratio of the corresponding sides. And finally, step 5, solve the equation. So let's look at this table. How can we set up a table of information? So here you can see I've got alpha, beta and theta, and I've got my small triangle and my large triangle. Now let's use the same example, but this time we're going to complete it using a table. So if we look at the small triangle ABE and you look at alpha 1, there's no length opposite AE. We don't have a length here, so we don't need to write anything down. Opposite B1, we have a length of 6, so we can write 6 into the table. The remaining angle is going to be A here, which is theta. So opposite theta we have X. Now look at the large triangle. So we're looking at ACD. Opposite alpha 2 there is no length, so we can ignore that. Opposite B2 we have a length of 6 plus 4, which is 10. And opposite theta is 7. So now we can use this information in my table of values to answer this question, from which we have 6 over 10, which is equal to x over 7, which gives me x equals 6 over 10 multiplied by 7, and so therefore x is equal to 4.2 centimeters. Once again, make sure you make notes on this recap, as the next example is going to be using it. Establish that the following pair of triangles are similar and hence find x. So in this figure, they've given us the information that this angle and this angle here are equal. So the first thing that we need to do is establish that these two triangles are equiangular. The first step's easy, since we know that angle AEB and angle ACD are equal. That's given information. Angle A is common to both triangles. Therefore, the two triangles are similar. So pause the video here and attempt to solve this problem by yourself. Try to use the table method. So you're working at me, it looks something like this. Since you already had alpha and we labeled this one theta, then the final angle ABE and ADC, we can call that beta. If I fill up my table of values, I've got my small triangle, my large triangle, alpha, beta and theta. Now I'm looking for the lengths opposite these angles. For the small triangle, the length opposite alpha, I don't know what it is. This 15 meters is for the large triangle. Opposite angle B would be x, and the length opposite theta is 6 meters. Now looking at the large triangle, I don't know what the length opposite alpha is. I know that's x, but I don't know what this part here is, so I'm going to leave that blank. Opposite beta, which is down here, we have 15, and opposite theta we have 10. So using the table, x over 15 is equal to 6 over 10. Therefore x is equal to 15 times 6 over 10. And finally x is equal to 9. So I hope you also got 9. Look back at your working out. If you did, well done. And if you didn't, no problem. Just make a few notes to show you working out. As always, thanks for watching. If you found the video helpful, drop me a like and subscribe. I'll see you in the next one.